Welcome to our pre-recording video. This is our statistics lesson, and actually we have 2 class worth of material here also. This is as usual the nature of the summer classes, that's why. So we have one here and like another is starting from here. But fortunately this will be manageable because I have arranged it that way. So let's have a look. So this is the agenda: mean, median, mode, then quartiles, range, and interquartile range. This is the first part. So for this first part, this mean, median, mode, what is this first of all? I mean, why do we study them? The reason is, these are the measure of central tendency. Central tendency. What is central tendency? Central tendency is the tendency of data to cluster around the central value. It means that, let me give you an example, then you will get it better. Suppose if you go to some class to investigate, suppose you go to some class of class 10. There are, let's say in the class 10, there are 15 students, total 15 students. Now, if you ask their age will be something like, let's suppose 16-year-old, 16, 17 years old, 6 years, then let's say 16 years old. Average. Class 10, 15 class, this is their class, total student is this. So you will notice that most of the students' age is around 16 years old. Suppose some people are 15-year-old 6 months, 15-year-old 6 months, 15-year-old, let's say 9 months. Some are 16 years old, let's say 3 months. Some are at best, let's say 16 years old, 5 months, then 16 years, then 16 years to 2 months. And some people will be at best 17 or 17.5 years old, and very few people will be 14 or 14.5. Very less people. But most of the people's age will be around 16 years old because they are in the class 10. This is how age group moves. This is called the central tendency. Most of the data are clustered around with the central value. You will never get a student, very unlikely that 5 years old, but in class 10. This is very unlikely. I mean, almost impossible. So most of the data wants to stay or cluster around the central value. If you go to, there are many practical examples of this. If you go to some slums, so if you want to investigate their average income, so since this is a slum, all the people are poor there, most of the people are poor there. We can say all even because this is slum. If they're rich, they will not live in the slum. They will move to some other place. So you will see that their average income will be clustered around some value. Not, of course, that will be very less in amount. So, and this is true for most of the thing. If you go to some rich place where all the rich people lives, you will see their average income is very high, and most of the people's income is very close to each other, unless there is any outliers who has very who is very rich, super rich. That's a different thing about the outliers. Outliers can stay in the statistics. That's why we have to mention it. Outliers means someone who is very different from the average group, but they have different reason for that. Suppose if you take the average of all the rich people in a country, you will see that the richest person is too rich. Usually it happens. And then if you take 20 people, then you will see that after there is a huge gap between the richest and the 20th people. This is There are reasons for that, but that they are called outliers. If someone is too rich, if someone is too poor in a group of people, they are called outliers. Suppose if you go, in our example, if you go to that class, and if you see some people really 5 years old, but in class 10, this guy is outliers. This guy, he is actually not representative of this data. Maybe this person is super genius, super talented, and I mean extremely talented, like 1 in 1 crore or 1 in 1 million billion even. This is possible, by the way. Sometimes it happens. You will notice that some people are that not 5 years, maybe 6, 7 years or 8 years old in class 10. They are too genius. Anyway, that's outlier, but still they are outliers. So central tendency means, let's come back to the point. Central tendency means the tendency of the data to stay around the central value. And how do we measure it is mean, median, mode. By using mean, median, and mode, we can measure the central tendency. We can find out the central value, then we can find out the tendency or how much data is clustered around, and we have some other measurement system also, which we will discuss in today's lesson. So let's look at what this mean, median, and mode, and how the other things works. Mean is just the arithmetic average. You take all the value, then divide it by number of numbers, then you get the mean. Okay, we take the number of numbers, we sum up, we add all the numbers, and then divide how many numbers. We have 1, 2, 3, 4, 5. And we have 5 numbers here, so this n means 5. Then 1 plus 3, so 1 plus 3 plus 5 plus, this way we will add all the numbers, then divide it by number of numbers, just like the regular average. Suppose you have 4 numbers, 3, 6, suppose 3, 6, and 8. So how you take the average? You add them, 4 plus 6 plus 8, divided by 1, 2, 3, 3 numbers, so divided by 3. Then you get the average of these 3 numbers. 18 divided by 3, that means 6. 6 is the average of these 3 numbers. This average is called mean, or the arithmetic mean. Mean usually will mean the arithmetic mean unless it is otherwise mentioned. Median. Median is when you arrange the data. Suppose you have the data orientation like 1 data, 2 data, 3 data, 4 data, 5 data. When you arrange all these 5 data, you take the middle number. Here I suppose it is let's say 5. Let's put it in 5. You take the middle number. Yeah, that's 5. That's also 5. Here also is 5. First we arrange the data, all the data in ascending order or descending order, both is fine. Then we take the middle number, that is called the median. Median means the middle arranged at a mid value. This is not affected by the extreme values. The reason is we are not taking the average. In our mean, in our previous in this discussion, actually this is affected by the extreme value. As I said at the beginning, if someone is too rich or if someone is too poor, then if you take their average, the whole average. Let me give you an example. Suppose we have 2 million income, 4 million income, and all of a sudden you have one people 20 million income. This is possible in our practical life. But if you take the average, suppose we have some few more people. Suppose 5, another person is 5, another person is 3 million, like this. So if we take the average of these people, 2 plus 3 plus 4 plus 5 plus 20 plus 20, then divided by 1, 2, 3, 4, 5% here. So we have here 2 plus 3 means 5 plus 5, 10 plus 20, 30 plus 4, 34. So 34 divided by 5. 34 divided by 5 means 6 point something, 6.4, so 40, 6.8. So 6.8. Now you see this, the average of this 3% is 6.8. Actually, this average is affected by this 20, because our most of the people's average income is 2 million, 3 million, 4 million, and 5 million. Yeah. This is the most people's average, most people's income. And if you take this average 2, 3, 4, 5, then basically answer will come around 3. 2 plus 3, 2 plus 3 plus 4 plus 5. Suppose if we want to investigate it more deeply, then what happens? This is divided by 4, 5, 10, 14, 14 divided by 4, that means 3.14 divided by 4, so 3.12 to 23, 6, 3.6. So average is 3.6. So whereas this 4 person's average is 3.6, but all of a sudden for this guy, our average goes beyond this 4 people. These 4 people maximum is 5, but our average should stay within the maximum people. But due to this extreme value, our average is now beyond the estimation, beyond our estimation. Estimation means, suppose what we think like, okay, if the average, there is 5% here, their average income is this, that means that all the people will be around this 6.8 million. But here most of the people's actually income is 3.6 million, and all of a sudden one guy is very too high. Anyhow, so conclusion here is this mean is affected by the extreme value. But you see, if we take the median, so median is what? If we arrange it, then it will become 2, 3, 4, 5, then 20. So if we take this is arranged data. So if we now take their average, take the mid value, this and this, suppose this and this gone, so average is 4. And 4 million is a better representation of their average of these people. 4 million is better than 6.8 million, because 4 million is coming close to the average of all the people. This 4 million looks better representation of the average of this 5%. So if there is outliers, if there is extreme value, actually our this median this guy helps. Okay, so median helps. That's not affected by the extreme value. Now one thing is we should mention is, if there is in our example we said that 2, 3, 4, 5, and 20. We said that this is our median. Now if we have one more value, suppose if we have another value is 2, then what is the median? Now there is no middle number, 1, 2, 3, 4, 5, 6. This is even number, so there is no median. So in that case we will take the mid 2 value and we will take their average. So median will be, in this case the median will be 3.5. Median will be 3.5. We will take that average, 3 plus 4 divided by 2. 3 plus 4 divided by 2 is equals to 3.5. So if n is odd, then we can take the middle number. But if n is even, just like this example, then we will have to take the average to find out the median. Okay. Then we have mode. Mode is the maximum occurring data in some data sets. That is the mode. Maximum times which number comes. For example, let's say we have one value like, suppose 2 million income is 2 people, 3 million income is, let's say, 5 people, and then let's say 5 million income is 1 people. Then you see this number comes most of the time. 5 people gets 3 million income. Then this 5 will be the mode. Mode is the maximum number. Which number comes maximum times? That is the mode. Here, 1 comes 1 time, 3 comes 1 time, then 5 comes 2 times. Then you see 9 comes 1, 2, 3 times. This box is just moved a little bit in the right direction. So this should actually be here. But just move a little bit this side. So this is 9. So you see 1, 2, 3. So we have 9 comes 3 times. That's why mode is 9. Mode means maximum time which number comes. That's the mode. Now you see in this example we can complicate this example. Suppose if we say that there are some people 4 million income is also 5 people. So what happens? 5 people, 5 people. Then there is 2 mode. Both of them is mode. 3 and 4 million. 3 and 4 million. Both is mode because both is 5 people, and they are maximum. But this is possible that there is no mode. If all of the value is same, then there is no mode. There is no maximum occurring data here. That is the reason. Okay. This is also not affected by the extreme value because we just look at the maximum number which one occurs. There may not be mode, just like this example. There may be several modes, just like this example, used for either numerical or categorical data. So for both cases we can use the mode. Numerical data and categorical. This is like the variable that we discussed in our last class. So in both cases we can use this mode. Now quartile. Quartile is also a way to measure, to understand the data better. What it does is quarter. Normally quarter means what? Quarter means basically 1/4 of the whole thing. Yeah, 1/4 of the whole thing. Suppose if you have some box here, and if you divide it by half here, and divide it by half here, then this is 1/4. This is called 1/4. This is called another quarter. This is called another quarter. This is called another quarter. So total 4 quarters means the one whole thing. So if we take the 25%, this is the first 25%, this is the another 25%, this is another 25%, this is another 25%. Total is 100%. Total is 100%. So after this first 25%, we call it first quarter, quartile 1. Then this is called quartile 2, quartile 2, Q2. Then this is called quartile 3. This is called quartile 3. We can find out the data in which quartile they are in. And how to find it out? There is a nice little formula here. Qi equals to I plus n plus 1 divided by 4. So if we want to find out first quartile, that means I equal to 1. Just like this example, I equal to 1. N means number of numbers. How many numbers we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 numbers. That means n equal to 9. Then quartile 1 we are trying to find out. That means this equals to 1. So 9 plus 1 into 1. 9 plus 1 means 10. 10 divided by 4. 4. This means 2.5. 2.5 means after the second data we will have our first quartile. 2.5. 0.5 means first data, second data, then 0.5 means middle of. In between these two data, we will have our quartile, which is actually 12. This is 12, this is 13, so 12.5 is our quartile 1, first quartile. If we arrange it here, it will be like in the first 25%, this is like 11 and 12. Just at this point, this is 12.5. 12.5 fifth number is there. So we will put here 12.5. We have more example of this in the coming slide. And if we want to find out quartile 2 is what, then we put here 2. Then we look at which number it falls, where it goes. Range is easy. Range means the highest minus lowest is the range. Highest minus lowest is the range. 12 minus 7 equal to 5. 5 is the range. Here also 12 minus 7 equals to the range. Difference between the smallest and the largest is called the range. Interquartile range. Interquartile range means we have three quartile 1, quartile 2, quartile 3. Interquartile range means quartile 3 minus quartile 1. Interquartile range is that quartile 3 minus quartile 1. So in our example, you have seen that our quartile 1 was 12.5. Our quartile 1 was 12.5 and quartile 3 is 17.5. Quartile 3. So if we subtract 17.5 minus 12.5, then we get 5. 5 becomes the interquartile range. Interquartile range means quartile 3 minus quartile 1. How to get the quartile 3? Our formula was I into n plus 1 divided by, this is I, divided by n. So divided by, the formula is right, divided by 4, because we have 4 quartiles, that's why. Yeah. Not this one, let's go to here. So we put here divided by 4 quartiles, that's why. I equals to, let's say 3, we want to find out third, then 9, total 9 data plus 1 divided by 4. Divided by n is right, divided by n is in the coming, you will see that. So 9 plus 1 means 10, 10 plus 10 into 3 means 30, 30 divided by 4. So 30 divided by 4 means what? 7, 7.5, right? 7.5. 28, then 2, 20, 4, 5, 7.5. Yeah, that's right. So where is our 7.5 data? This is one number, 2, 3, 4, 5, 6, 7. So this is 7 number data, but we have to go 0.5. 0.5 means we have to go half more. So between 17 and 18, half means full is 1, half means 0.5. That means 17.5 is the middle. 17.5. That's why our quartile 3 is in the 17.5. And when we subtract 17.5 and 12.5, this is called the interquartile range. These are some practice problems. We will try to do these maths during the class, mean, median, mode from this data. These are also the same practice problem. Then this comes the second part of this lesson, which will discuss variance, standard deviation, symmetric and skewed, box and whiskers plot, and the what. So what is variance and all these things? What it does is, this is like some deeper analysis of the data distribution, like how the data is spreading. Are they close to each other? Are they too separate from each other? What is going on, like that? All right, so let's look at this thing. The variance. Variance is the spread of the data. How the data is. Are all the data. We have an example actually in the next slide. So variance is, it will show us that how the data are distributed. Are all the data is closely packed, or all the data is too far away from each other, or are the data is like too far away from the central value, or the data is close to the central value. We will understand it from the variance and standard deviation from both of them. The formula for finding the variance is, we have two formulas. One is for the population and one is for the sample. For the population means if we take the variance from all the people. In our in our example, suppose if we take some analysis from, if we go and analyze it from our university students. Let's say we have 900 students, and if we investigate some experiment, if we do some experiment from all the 900 students, then this is called for the population. Population means this one. But if you take the sample, then this formula. Sample means, suppose from all the 900 students, we will not take the we will not do the experiment, or we will not take the data from all these 900 students. So let's say we will take the sampling system. We will take some students from UG1, UG2, like that. Then let's say we take the data from 100 students, then this formula for the variance. For the sample, this formula; for the population, this formula. And in the data, it will be mentioned: is it sample data or is it population data? This is how we find out the answer. So let me show you what does, because in the next slide it comes directly standard deviation. So the difference between variance and standard deviation is, you see, sigma square equals to, this is called sigma square equals to this. Then if you find out only sigma, then this is square goes to the other side, it becomes a square root, then it becomes standard deviation. When you take the square root of variance, then it is called the standard deviation. Here also same, this square goes to the other side, then it will become a square root. Just like this space, it becomes a square root, then it is a standard deviation. So how to find it? Suppose how to find this and how to find this. Both is same thing, by the way. See, this one and this one. Let's look. So you see, we have this data here: 10, 12, 14, 15, 17, 18, 18, and 24. The mean is 16. Mean means this plus this plus this plus this plus, then divided by total number of numbers, which is 8. So here we said that n will come here. So we have n here divided by. Then according to this formula, this is xi minus mu square. Xi means take the average. Xi means this is the xi means numbers. Mu means the average. Xi means this first one, second one, third one, like that. So 10 minus 16, because first one is 10, then 16 is the average or mean, then whole square. Xi minus mu whole square. Then xi, in place of I, it will become 1, 2, 3. That means first number, second number, third number. So second number is 16, 12 minus again 16 whole square. Then this number 14 minus 16 again whole square. So this will be repeating. Then 15 minus 16 whole square. Then 17 minus 16 whole square. 18 minus 16 whole square. 18 minus 16 whole square. Here actually we have some mistake. 18 minus 16. So we can give here a 2 here. Let me edit it. Let me change it. By small, there is a small mistake here. Yeah. So here, so 18 minus 16 whole square. So let's first of all let's keep this square whole square, and you can see there is 18 two times, 18, 18. So instead of writing it twice, we can just give here 2. Then 24 minus 16 whole square divided by 8, then is square root. So, and we will have to do the square root from the everything. So let's give a bracket here. Now this is more accurate, because everything then is square root. Everything then is square root. Save it. Yeah. And when we do this, we get our final solution 3.9689 from here, after doing this square root. So you can see that finding standard deviation is actually, it takes time if we have a lot of data. That's why usually in the calculation you will get like this much of data, not too many. If we have, let's say, 100 data here, then it will be like a really marathon of calculation, then it will become. But hopefully in our case, it will be like not too much, like this much data. Yeah. So for sample and for the population, it will be a little bit different, and we can see that the standard deviation is larger for data considered as sample. If it is sample, then it is a little bit bigger, and it is better. Bigger is better because bigger estimation is better estimation. This is due to n minus 1. This is due to n. N minus 1 means 1 less. So you are dividing by a less number. That's why value is more. and you are dividing it by a more number, that's why value is less. Anyhow, so they have for the same math we can find out for the sample and for the population, and they will be little bit different in the answer, close but little bit different. And which formula you will have to use, it will be mentioned in the whoever may ask you the question, is this data is sample or is this data is whole population, it will be mentioned. Just like this one, you see what is the what it tells, or how do we what we understand from standard deviation. See here, all the data are very closely packed. That's why standard deviation is very small. Deviation means how they deviate. They do not deviate here. This data set, they do not deviate here. This will be data set B. This will be data set C. We'll try to do this one in the class. And so for the data set, you can see that these data are not they are not spread, they are closely packed. That's why standard deviation is very small. But here the data is very too spread, and data is scattered too much in the data set A. That's why standard deviation is bigger. And if you get this standard deviation value is more, that means the data is more spread. That some data is here, some data is here. Then the S value will be like 5, 7. But if S value is very small, it means that the data are very close to each other. Okay. From the shape also we understand how the data are distributed. How the data are distributed, we can understand it from the shape. This is called skewed or symmetric. If the data is very balanced, only all the values are in the central place, and then we can actually see that this symmetric structure. We will have example in the coming slide. But in sometimes we can have many data in the left side, and then all of a sudden some higher value, and we can have like most of the data, this is mode, all of a sudden a lot of data is here. That's why our curve actually have this shape, left is skewed, right is skewed. Let me show you with the data, some data. This one actually tells about that. So suppose if we look at this data, this will be the symmetric. This data will be symmetric because most of the data is in the central value, and all of them are actually balanced in the left side and in the right side. This will be the central. Symmetric. This data will be the symmetric. Yeah. But if we have many data in one side and many data in one side, it is spread too much. This side it goes too much linear. Just like our outliers example. Suppose this slide is, let's say we have 1, 2, then 6, 6, 6, then all of a sudden 7. So you see 6, 6, 7, but all of a sudden 1, 2, our head of this thing will come here, but you see one side will go just like to balance it to 1 and 2, to balance this 1 and 2. This side has to go to the other end to balance this small 2 value. And yeah, so that's why we have this kind of actual data in our real life. Sometimes all the data is balanced, then we have symmetric. Sometimes some data actually goes in one side very much, too much, then it becomes skewed. If in the left side some data goes too much, then left skewed, and if in the right side some data goes too much, too far away, then we call it right skewed. We can actually analyze it from our bar diagram chart, bar chart also. We can analyze it. In this case, where we see most of the bar is here. The highest bar will be here in the mode. Mode means the highest bar is where. Yeah. And this side goes in the other side, means there is a small bar here, small bar here, but highest bar is somewhere here. Also, we can understand it from the distribution of mean, median, and mode. In the left skewed, our mean is in the left side. In the right skewed, our mean is in the right side. Mean means average in the right side, but our mode comes to the mode is always in the highest peak. Mode is always in the highest peak, by the way. Median is in between. But they can be sometimes very close to each other also. This mean, median, mode, but still there will be the relationship. Mode is always in the peak. So we will have to look at the mean to understand if it is left skewed or right skewed. Okay, mean will give us the main idea here. If mean, median, mode is same, then it is symmetric. If mean is in the left, then left skewed. If mean is in the right, then right skewed. This is the last one. Is it the last one? Yeah, this is the last one for our this class. This is box and whiskers plot. This is a box, and this side, this is called whiskers. This is called whiskers. How to construct it? When we have some data, we find out their small. We can understand their smallest value is what, largest value is what. We can find out their median is what. We can find out their quartile 1 is what and quartile 3 is what. Then we plot it in terms of the scale. Then we get the box and whiskers. We have example how to do it in the next slide. This one. Suppose we have this data. 14, 6, 6, 3, 2, 4, 15, 11, 8, 1, 7. This is the data. These are the owners of a restaurant wants to find out more about. This is about how far a customer comes to the restaurant. Suppose 16 miles away some customer comes. 1 mile away some customer comes. So this restaurant owner is trying to understand his customer's distance, from how far they come and where is the mid value, etc., etc. So let's say he wants to get a box and whiskers plot. So first of all, what he will do is he will arrange the data. He will find out the median. Median means the arranged data mid value. You see there is 1, 2, 3, 4, 5, 6, 7, 8. 8 data this side. Then 1, 2, 3, 4, 5, 6, 7, 8. 8 data this side. So middle is at 6. That's why this will be the 6. So median is here. Median is here. This is median. This example, I have taken this example from Khan Academy because I thought that this is a nice example. That's why. So this is the median. This is the median. This is the median. So in the middle of this box, always we will put the median value. This is the scale. Our scale is from 1 to 22. So let's say from 0 to some value we can give. Then 22 is here. So our lowest value is 1. That's why our in the whisker lowest is 1. Our highest value is 22. So that's why in the whisker. This is called whisker. Whisker means the extra space. This is called box and whiskers plot. So box is this box and whiskers means the extra space. Okay. Now we know how to find out this value because this is lowest. We know how to find out this value because this is highest. And we know how to find out median. Okay, now what about this value and this value? This is actually the quartile 1, this is actually the quartile 1, and this is quartile 3. How to find it out? The process is not hard. You see, this is the middle. We already know that. So now we have to come to this part up until here. So what is the mid value here? What is the another median here? In simple words, here we have 1, 2, 3, 4, 5, 6, 7, 8 data. 8 means even number. For even number, we have to take the average of middle 2. So 1, 2, 3 gone. 1, 2, 3 gone. That means this 2 number is in the middle. So 2 plus 3 divided by 2. That means 2.5. So 2.5 is here. That's why it is quartile 1. Similarly, the mid value here is what? The median here is what? Median here is 12.5. That's why 12.5 is in our quartile 3. So in the box and whiskers, we will put quartile 1 at the beginning of the box, and we will put quartile 3 at the end of the box. Then the highest will go for the whiskers, lowest will go for the whiskers. Whisker will start in the lowest, whisker will end in the highest data. And when we show it in the arranged data, then it gives us some sense. Our median is here at 6. So median is very close to this box. This side is actually small. That means there is a lot of data here. And this side is spread. That means data is little bit spread in the other side. Our median is, think about it. Physically, what does it mean? Physically, it means is 6 is the median, but you see this side after the median, this is already in the middle. This is the middle. So from the middle, this side is just only 1 to 6. That means 5 away. But this side is 22, from 6 to 22. That means 6. That means 16 away. So although you have same number of people, but this same number of people is too spread, too scattered, but they are closely packed. That's why our box, in the box and whiskers plot, this is the middle, and from middle to this distance is small. That means many people are here, and this from here to here is the distance is too high. That means less people are here. So from the box, by looking at the box, we actually understand a lot of data. That's why this box and whiskers plot also helps us to analyze the data. By looking at the box, we actually understand it. Let me recap. There is actually 25% of the people here, 25% of the people here, and then another 25% of the people here, and then another 25% of the people here. Because as you can see, due to the median distribution, due to the median calculation, we know that. So anyhow, this box and whiskers plot actually helps us to understand how the data are spread, how the data are distributed. This helps us to understand it. How this helps us to understand in our statistical analysis, statistical calculations. This is the relationship with the box and whiskers and with the symmetric and skewed data. This is the relationship between them. So you see, if our left side is too spread, as we said, left skewed, and that's why this is the middle, this is the median, this is the median. See the median data. And this side is too spread, that's why this side is bigger. And for the symmetric, the median is in the middle, the median is in the middle, mean median mode, everything can be here. So median is in the middle. This is like another example. But our left side and right side, both side is same size for the symmetric data. For the right skewed, as we said, in the right side we have data is too spread. In our left side, data is less spread. Okay. In the right side, data is too spread. Data is little bit far away in the right side. Okay. So if I ask you now this question, in this example, is it left skewed or right skewed data? Think about it, and we can discuss it in the class also, because this is it skewed or not skewed, it is not written. So you can actually understand it from this figure also, Okay. Also from the shape of this shape and this shape. This kind of maths we will try to find out. We will try to do these maths variance and standard deviation. During the class, we will try to do this math, and think about it. Which one is left skewed, right skewed? And think about it. What can be the answer? We can discuss it during the class. Oops, these are the answer. This is actually the answer. Anyway, so that's all. That's all. Thank you all. Thank you very much. This is little bit. Actually, this is the uh, uh, last lesson for our for this semester, for the summer semester, and there will be no new lesson, no new material for this semester. In our next video, that will be related to the revision. So nothing new. We will not bring anything new. This is the last lesson for the semester, as you said. So, all right. Thank you all. Thank you very much, and see you all in the class. And have a look on this, and we'll discuss. Okay. Have a good day, everyone.